Oh, we've already started. I need to add. Um, let's go to the ladybug here. I know that clicking is terrible. All right, I needed to add one more thing. This is your average speed. Okay. Now, when we're going to watch Elaine Thompson do this 100-meter dash, she ran the time. Her time was 10.71 seconds. That was her time. Now, Olympic athletes, well, all sprinters, when they take off, they got a huge acceleration. They do not maintain all of these kinematic equations pertain to a constant acceleration. They really don't keep one. Okay, so actually, her time was the average time. Okay, was her time dealt with the average speed that she had because really what happens is at the end of a race in any dash now, distance running is completely different, as we saw in the marathon video. Well, as you're going to see in the marathon video in the next at the start of the next chapter. You can have a sprint at the end in marathons, in the mile, um, uh, the 5K, the 10K. You're going to see the athlete sprint at the end, but in a sprint they burst out of the blocks at the very beginning. They just explode out of the blocks at the very beginning, and then with a huge acceleration. And then the winner is the one who slows down the least. Okay, the winner is the one who's got the greatest, or does not slow down as much as the others. They do not. There is no such thing as a kick at the end. It's just that the one who maintains his speed the best, or he or she looks like they're going ahead of everybody. They're just slowing down less. All right, and that's the same thing that happens here. You'll see her break away from the pack. It looks like that's because everyone else is kind of slowing down, and she's being able to maintain her slowing down her speed a little bit better. But they all start to deaccelerate because they bust out of the blocks at almost 1 g at about 9.8 meters per second squared, or close to. The women that's what male world class sprinters do. She may not have that, but this is her. So we're going to calculate her average. So we're going to calculate what her average speed was, and um, if we can find her average velocity, we could probably find her average velocity because we could probably find her average acceleration too for the entire time, because we're going to use this equation to find her average acceleration. All right, she did not keep a constant acceleration. So we'll just try and find her average based on, we know she went 100 meters. Her initial velocity was 0, and we'll work those out. Uh, I'll post those problems, and then I'll have a video where we work them out. Okay.